Welcome to Chapter 6. Chapter 6 is all about radical equations, radical functions. The book jumps right into Chapter 6. We're going to review some properties of exponents, things you should have learned. Hopefully you learned in Algebra 1. But maybe you didn't, or maybe you forgot. So quick review here. There are 7 properties of exponents. The first one says if I multiply two things that have exponents but the same base, that's a giant times sign. I don't know what happened there. That says a to the m times a to the n. When that's the case, hopefully we remember that we add the exponents. That's going to be a to the m plus n. Second property, when I divide things that have the same base, we subtract their exponents, a to the m minus n. Property number 3 is called the power of a power property. So I have a to the m, and I raise it to the n power, a to the m to the n, power of a power. We multiply the exponents when that's the case. That's a times. Property number 4, anything to the 0 power we know is 1. Number 5 and number 7. 5 and 7 are very similar. It says if I have a product a times b or a quotient a divided by b, and I raise that to the n power, I can distribute and say that's a to the n times b to the n. Or I can distribute here and say a to the n divided by b to the n. Notice there is not a property, we'll talk about the 6th one here in a minute, but there is not a property that says a plus b to the n. I cannot distribute and say that that's a to the n plus b to the n. That would be incorrect. Also, minus does not work. If I have something like a plus b to the 3rd, remember that's where we use Pascal's triangle to expand it, which would not just give me this. So we can distribute the exponent if I have a product or a quotient, but not a sum or a difference. And then hopefully also we remember that negative exponents should never be in our answer. If I have a negative exponent, I move it. If it was already on the top, I move it down to the bottom, and I make the exponent positive. If I don't have anything left in the numerator, I put a 1 up there. If I had a negative exponent in the denominator, I would move it to the top and make it positive. Couple relatively quick example problems dealing with properties of exponents. Example 1 asks us to simplify. Part A says x to the n z to the negative 3rd divided by x y to the 4th z to the negative 7th. X to the 9th z to the negative 3rd over x y to the 4th z to the negative 7th. Looks like we're dividing, so when we divide, we subtract exponents. So the x is 9 minus, that's understood to be a 1, so that would be x to the 8th. Z's, I have negative 3 minus negative 7 is 4. And I don't have anything to combine the y to the 4th with. It was on the bottom, so it should just stay on the bottom. X to the 8th, z to the 4th over y to the 4th. Part B, we have 3x squared y, all raised to the negative 2nd power. 3x squared y raised to the negative 2nd power. I only have products in here. I don't have any plus or minus, so I can distribute this negative 2. So it's going to say 3 to the negative 2nd, x squared to the negative 2nd, y to the negative 2nd. So I raise each thing to the negative 2nd power. Right here, The x's, I have power of a power. When that's the case, I multiply the exponents. That'd be 2 times -2 is -4. I should not have negative exponents in my answer. I need to move them. 3 to the second goes down to the bottom, as does x to the fourth and y to the second. I don't have anything in my numerator, so I put a 1. 3 to the second I can simplify. That's 9. 1 over 9, x to the fourth, y to the second. Example 2, same directions. We're still using the properties of exponents. It asked me to simplify that big gross thing. Notice one thing I cannot do is I cannot distribute this to the 0. I can't raise this to the 0 plus this to the 0 plus this to the 0 because I'm adding in there. Remember, that only works with multiplication or division. Instead, earlier we said anything to the 0 power is 1. So this to the 0 power is 1 plus x to the 0 power is 1, and 1 and 1 make 2. Part B, we have 4x cubed y over 10x squared times 5x cubed y over y cubed. There's lots of different ways you could do this problem. I think the easiest way to do it is to just multiply straight across first. So do 4 times 5 is 20. X cubed times x cubed. When I multiply, I add the exponents. Y times y is y squared. On the bottom, I've got 10x squared y cubed. Now I'm dividing. 20 divided by 10 is 2. X to the 6th divided by x to the second. When I divide, I subtract exponents. 6 minus 2 is 4. 2 minus 3 is -1. And negative exponents go in my denominator. 2x to the fourth over y. So that was 6.0. 6.1 is on roots and radical expressions. So chapter 6 is all about radicals. We'll talk about multiplying and dividing them, adding and subtracting them. We'll graph radicals. We'll solve radical equations. Today we're just going to define what radical expressions are, talk about roots, and talk about how to simplify radical expressions. So 5 squared is equal to 25. Hopefully we can all agree on that. So 5 is called the square root of 25. So if something squared equals something else, we say that first something, in this case 5, we define that as the square root. 5 cubed is 125. 5 is the cube root. Five to the fourth power gives us 625. We don't have a special name for roots past cube roots. They're just called fourth roots, fifth roots, and so on. 5 is the fourth root of 625. Example 1 asks us to list all square roots of 64. We need to list all the square roots of 64. And I think hopefully we can recognize very quickly that 8 is a square root of 64. Based on what we just talked about, is negative 8 a square root of 64? We said since 5 squared was 25, 5 was the square root of 25. Negative 8 squared is 64, so negative 8 is indeed a square root of 64. 8 and negative 8 are both square roots of 64. Now this does not change what this is equal to. This is asking for the positive square root of 64. This notation means I want the positive square root of 64, which is just 8, not plus or minus 8. If it wanted the negative square root of 64, it would have to have a minus sign out front. So this notation, root 64, written like this, is only 8. If it wants to know what are the square roots of 64, that is 8 and negative 8. How about square roots of negative 64? We're only talking about real numbers here. What real number squared is negative 64? There are not any. If I square a number, I always get positive. Cube roots of 64. What cubed gives me 64? 4 times 4 is 16, times 4 again is 64. What about negative 4? Negative 4 times negative 4 is 16, times negative 4 gives me negative 64. So 4 is the only cube root of 64. Negative 4 is the cube root of negative 64. The notation we use for roots looks like this. This is read the nth root of a. N is called the index. That tells us which root we are taking. So a cube root looks like that. A fourth root looks like this, and so on. A is called the radicand. That is the number we're taking the root of. Notice for a square root, we don't write the index up here. Usually that's the case in math. Whatever the most common one is, it's just understood to be out there. Like if I have 3x, that's understood to be x to the first. That's the most common one, so we just don't write the 1. Square roots have an index of 2. Even though we don't write the 2 up there, it's understood to have an index of 2. The principal root, we actually already talked about that. That's just the positive root. So I'm talking about this notation that is equal to 8. The principal root is the positive square root of 64. So when we write the notation with the square root symbol, that is actually the principal root. That's not asking us to find all square roots of 64. Example 2, let's simplify some radical expressions. In part A, we're given the square root of 4x to the 6th. And the square root of 4x to the 6th. So we want to be thinking what times itself gives me 4x to the 6th. Well, the square root of 4 is 2. The square root of x to the 6th, notice if I'm thinking x to what power and then squared is going to give me x to the 6th. This needs to be a 3, power of a power. I would multiply these. (2x cubed). Notice we can figure that out. The square root of 4, we know. Square root of x to the 6th, if the number's in the exponent there, what I can do is take the exponent and divide by the index with the square root. It's understood to be dividing by 2, gives me x to the 3rd. Part B says the cube root of negative 27 y to the 15th z to the 6th. The cube root of negative 27 y to the 15th z to the 6th. First of all, can we take a cube root of a negative number? We can because it's odd, because the index is odd. I can take a root of a negative number, because if I multiply a negative number by itself an odd number of times, I do get a negative. So the cube root of negative 27 is negative 3. Negative 3 times negative 3 times negative 3 gives me negative 27. And then, like I mentioned over here, the easiest way to do this is just 15 divided by 3, so y to the 5th. Notice if I take y to the 5th to the 3rd, 5 times 3 is 15. Z to the 6th divided by, 6 divided by 3 gives me z to the 2nd. Negative 3, y to the 5th, z squared. Example 3. Example 3 looks very similar. It's actually a little more difficult. We're given the cube root of 16x cubed y to the 14th. The cube root of 16x cubed y to the 14th. The problem we're running into, 16 is a perfect square, but it's not a perfect cube. So when that's the case, remember when we had like square root of 50, we would split that up so part of it would come out even and part of it wouldn't. And then we'd get 5 root 2. So that's how we want to take care of this. So 16 is not a perfect cube. We need to find a factor of 16 that is a perfect cube. Well, that'd be 8. 8 times 2 gives me 16. And the cube root of 8 is going to come out even. X cubed is a perfect cube, and we know because 3 divided by 3 comes out even. So I'm just going to leave the x cubed under the root here. I don't need to split it up because that part's going to come out even. And then y to the 14th. 14 divided by 3 does not come out even. So I need to split up the y's. We need a number smaller than 14 that when divided by 3 does come out even. And I want it to be as close as 14 as possible. Otherwise, I'm going to have to simplify some more later. So a number less than 14 that is divisible by 3, as close to 14 as possible. And hopefully we came up with 12. I can't just change 14 to 12 though. This needs to be times y to the 2nd, because 12 plus 2 is 14. And now we're going to simplify the ones that can be simplified. The cube root of 8 is 2. Cube root of 2 does not come out even. Cube root of x cubed, 3 divided by 3, that's x to the 1st. 12 divided by 3 is y to the 4th. And then the ones that do not come out even stay under the cube root. So I've got times the cube root of 2y squared. Let's try another one. Part B says the cube root of negative 81 a to the 8th. The cube root of negative 81 a to the 8th. 81 is not a perfect cube. Perfect cubes, remember 1 cubed, 2 cubed, 3 cubed, 27, 4 cubed, 64. 5 cubed is 125. We need to find one of these that is a factor of 81. Should be 27. So let's split that up to negative 27 times 3. 8 divided by 3 does not come out even. So we need to split up the a to the 8th. We're going to split it up as a to the 6th times a to the 2nd. 6 is less than 8. It is divisible by 3. A to the 2nd because 6 plus 2 is 8. And now we write our answer. Cube root of negative 27 is negative 3. Cube root of a to the 6th, 6 divided by 3 is a to the 2nd, times the cube root of 3a squared. Part C, square root of 99, x to the 5th, y to the 12th. Square root of 99, x to the 5th, y to the 12th. Start with a 99. We're going to split that up as 9 times 11. Nine's a perfect square. 5 divided by 2 does not come out even, but 4 divided by 2 does. So I'm going to split that up into x to the 4th times x to the 1st. 12 divided by 2 comes out even, so I'm going to leave the y to the 12th alone. Square root of 9 is 3. Square root of x to the 4th, 4 divided by 2 is x to the 2nd. I've got y to the 6th times the square root of 11x. And usually you will see this time sign written in here. The reason we do that is if we don't put it in there, it's tough to tell if this is y to the 6th times the square root or y times the 6th root. So usually you'll see the time sign in there to differentiate between what's out front and what goes under the root. That's it for today's notes. See you guys soon.